We're excited to announce our next speaker. It's Dr. Michele Champagne, and she's going to be joining us virtually for the next presentation, and it's entitled Tapping into Fermentation for Sustainable Foods. And Michele Champagne is the founder and CEO of Champagne Consulting. He works with startup companies and venture investors in the food tech and biotech industries. Her expertise in fermentation-based technologies includes sustainable alternatives to animals and petroleum-derived products.
Well, I'd like to thank Mi Fong and the Aquilius team for inviting me to join you today remotely. Trust me, I'd rather be there in San Diego with you today because I'm just wrapping up the last 6 months in rainy Eugene, Oregon. I could use a bit of sunshine. But unfortunately, I'm on my way to Colorado where I normally live this week. So San Diego is a bit out of my way. But I'm grateful that you guys are willing to host me and allow me to join your sustainability symposium today. So thank you. As you heard, my work right now focuses on food technology and supporting startups and investors in their diligence into the food tech space. And I think if I heard correctly on the last presentation, the number on the percent CO2 emissions that is contributed by food was about 6%, I think, if I saw that correctly. So while 6% may sound like a small number, I still think it's significant and worth pursuing. And what I'd like to do today is walk you through some of the ways we've been using fermentation historically, how we're using it now in some pretty exciting new ways to hopefully develop more sustainable ways to supply food and other products, and then get into a little bit of some of the challenges and some of the more promising trends that are coming ahead. First thing I'd like to do is call out that within the sector I work in, there's a new buzzword for an old word, which is essentially precision fermentation. This is what's going around the last couple of years, and fermentation should be pretty recognizable to most of us, but the precision part is a bit new. And so what I'd like to do is basically back up a bit and talk about how fermentation has been a part of all of our lives for as far as we can remember, really. I dare say pretty much everyone listening in today has consumed one or more of these products, and so you've been a beneficiary of fermentation. And even beyond the foods that you're consuming, within your gut, you've got bacteria who are doing the job for us, converting some of those inputs and fats and starches into other byproducts that are quite beneficial, as we're coming to learn now. The conversion of these substrates into short chain organic fatty acids is quite beneficial to our mental health and our overall physical health. So there's nothing really new here, but if we take it a step further, now I'm moving into a natural precision definition of fermentation. So rather than working with a complex mixture of microorganisms leading to a food product with a complex composition, now we're selectively cultivating individual microorganisms that naturally produce compounds of interest for us in large-scale fermentations, and then we're isolating specific compounds for food and other nutritional benefits. There's a very, very long list of these compounds. I'm going to try to keep on track with the overall time today. So, if you want to get into these in more detail, I'm always happy to talk about this. I've spent a fair amount of years working on these compounds as they're related to food and nutrition. But where we can make the biggest impacts, I think a lot of us have come to appreciate that our meat consumption, animal-based products have a significant CO2 footprint. And so a lot of us have started moving our fermentation efforts into making replacements for animal meats and dairy-based products. While almond milk, as I recently learned, has been around for quite a long time, there were some other meat alternatives right around 1985 doing fermentation using fungi. They have a great texture. I don't know if the flavor is all that great. It's hard to convince a carnivore to switch from meat to something that's not meat. But These products have been around and they're growing in uh, awareness and availability, and the costs are coming down on them. What's particularly exciting in the recent years now is working on very specific animal proteins that are in use in high volume. So if you're following the issues with avian influenza virus and you've seen problems with the price of eggs and the supply of eggs, you can appreciate that maybe having a precision fermentation approach to producing egg whites and even whole eggs might be an advantage for us. Milk proteins, there are a number of milk proteins, casein, whey, that are now being manufactured through precision fermentation, and even some highly nutritional compounds that come from milk, such as lactoferrin, which is an important nutritional compound, especially in breast milk for infants. So there's a lot of work going on in that. There are also some interesting combinations of fermentation and plant-based approaches. Um, I'll be honest with you, my opinion on cell culture as an alternative to animal meats, I have a lot of reservations about the ability to come up with a meaningful carbon dioxide reduction from switching to these processes. They're highly complex and highly expensive to scale. And I think there's still quite a bit of work to be done before those become available in any meaningful volume and at a price that most consumers can afford. Not to mention dealing with the consumer acceptance that needs to come along with those products. But there are companies that are trying combinations of blending plant-based ingredients with those, or just making plant-based products, for example. And to that end, there are mushroom-based products that are actually quite tasty that are available now. And there's even a company that's making duck liver pate through precision fermentation. So there's quite a bit of creativity going on out there. One thing that I find particularly exciting is, the movement away from a hyper focus on proteins per se. That started right around 2014 when we were forecasting with population growth and the needs to supply enough protein for the population. And so, really, the early efforts to date have focused on proteins, but people are becoming much more aware in the broader sense of how our food consumption patterns and the supply chains affect greenhouse gas emissions, and then how the environmental changes are affecting the supply and availability of some of these products that we consume. I'd wager that as you look at the examples on the upcoming slides, you consume all of them almost on a daily basis. Maybe not chocolate, but so if you think more broadly about the impact beyond just beef, if we start getting into these other products in our food supply chain, then it's easy to see how we can have some meaningful impacts on sustainability and greenhouse gas reduction. There are, again, different approaches to this. Some companies are focusing on using existing plant-based ingredients and reformulating them to come up with alternatives to chocolate. Or, there are companies such as Planet A Foods, which is trying to do a precision fermentation approach, um, making the individual flavor compounds and fats to recapitulate a chocolate product. I did want to call out, if as you see some of these names come up in the presentation, there's no explicit endorsement. There's certainly no paid endorsements here, but I'm just using them as examples. Coffee, again, if you may be starting to see we're having issues with the coffee supply chain again because of environmental changes. So we have a company based out of San Francisco that's been trying to do precision fermentation to replace coffee. And then there are groups that thankfully are working on traditional plant breeding approaches, trying to improve the resiliency for coffee crops. One of the areas I've been spending a fair amount of time helping companies, especially in the regulatory support space, is fat. And if you think about it, a food product that lacks fat also lacks taste. And so the likelihood that you're going to buy even a plant-based meat alternative or dairy alternative, if there isn't a sufficient amount of fat blended into it, the taste and everything is just not going to meet up with your expectations of an animal product, right? So replacing fat in a more sustainable way is also an important component of getting our dietary patterns into a more sustainable approach. There's a couple of companies that are working on alternatives to palm oil through precision fermentation. There's a very exciting approach that is promoted by Savor, where they're taking CO2 and going through a thermochemical process to convert that into fats. So there are a lot of exciting efforts going on in the food ingredient space per se. But I think I like to think about food more broadly than just the ingredients. I like to think about all the things that we're impinging upon as we're manufacturing, packaging, and transporting and storing our foods. And so it's pretty easy to see that we can make some dents in the sustainability and greenhouse gas emissions through our packaging. We heard some great talks today on plastics, and the footprints of plastics and the health risks associated with them. This is an area that people have been digging into for quite some time, right? We heard about polyhydroxyalkanates earlier today. Those degradable utensils and packaging are available. I'd like to see them made more available. People have been working on edible packaging with limited success. And there are other approaches to reducing spoilage on the shelf. But this is an area that I'd really like to see the precision fermentation tech sector lean into more heavily to help us. Another area that's been pretty exciting and promising is on upcycling or recycling of waste streams. So there are a couple of companies I'm aware of where they're either turning food waste into end products. So we talked a minute ago about natural preservatives. Those fermentation processes that I mentioned earlier are typically very specific uh, cultures, right? So there's just one microorganism that's doing the work for you. BioVeritas is working on converting food wastes, which is a very complex mixture, into making those preservatives naturally, and reducing stuff going into landfills. There's a company called Aquacycle that is also trying to clean up wastewater coming out of food manufacturing facilities. It's another process that ostensibly could reduce methane emissions and the sludge coming out of our municipal treatment plants. One thing to keep in mind with these processes, because they're mixed cultures and because the inputs are complex, that these are more difficult to control and it's harder to have a reliable process and product coming out of them. So while it's important to continue the development on these waste streams, keep in mind that they're a little bit more challenging to come up with a consistent product. Other areas where precision fermentation and just fermentation in general are making some advances is in dyes and textiles. There are both fungal-based approaches to making leather as a replacement. There are companies using recombinant bacteria and yeast to make silk alternatives. Companies using seaweed to make textiles. So this is broader than fermentation per se. Um, but all of this adds up, right? Everything we do in an industrial sense has a footprint. Um, there are recently, within the last few years, a number of companies have gotten into the space to make dyes as a replacement using precision fermentation, and I'm hoping that those are going to be both environmentally uh, safer approaches, better for your health, better for the environment, and better CO2 footprints. Keep in mind that we're never dealing with a level playing field. Historically, these processes have used sugar as a input for the fermentation, and when you're going up against subsidized animal products or petroleum, it's very hard to compete on a price basis alone. And if you think even further about the amount of effort it takes to turn around all these industries, it's significant. We've got millions and millions of acres that are committed to soy and corn in this country. It's going to be difficult to both discontinue the government subsidies and get the benefactors and the stakeholders in that system to change. And so for that reason, I do expect precision fermentation will continue to focus on corn sugar as a primary input in the near term, rather than the complex waste stream inputs. Also, this is one reason that you haven't seen a lot of commodity products coming out through precision fermentation. When they're competing on this basis, they've had to turn their attention to some very high margin, low volume products. One area that I'd like to see startups do a little bit better job, so we have a higher success rate, is that they have to really lean into the consumer unmet need. A lot of these techs emerged from an animal-free perspective, which is terrific, right? But what many of them have failed to do is understand where the consumer is coming at, so that they can tailor their technology to what consumers are needing and interested in. It's very easy for us tech interested people, when we have a hammer in our hand, we think everything's a nail, right? And that's not necessarily the case. So this is an area where we're seeing improvements, but we need more improvements, and a lot of that is coming about through partnerships with large CPG companies, consumer packaged good companies that have that consumer intelligence. Technically, these processes have some limitations inherent in them because they're a biological system, and the most common one is product inhibition. So, as we discussed, these compounds are not necessarily natural to the organisms that we're engineering them into, and for that reason, if you start growing them in a closed system where you're producing a lot of product that they're not accommodated to, it inhibits them and it shuts the system down. So end product inhibition is a very classic problem. There have been a number of efforts developed at an engineering level to try to alleviate that by pulling the end product away from the microorganisms, the live microorganisms, to keep them live, keep them producing. Some teams are trying to go a step further and actually opening up the engineered cells, if it's a largely enzymatic process, and then just doing this as a chemical transformation. Some other challenges that we've faced in this sector over the last decade or so is that, with cheap money, people have been relying very heavily on dilutive VC as a funding source. I think that's clearly experienced a 180-degree turnaround over the last couple of years, and companies are increasingly moving in towards these public funding sources. I found back in the 2000s, the SBIR programs and STTR programs are very effective ways to get a startup initiated, but these aren't sufficient sources of funding for the later stages of development growth for these companies, because they're capital intensive in many cases, and the funding sources often don't go up beyond $1 million at best. Um, Another historical issue that has been faced is access to manufacturing infrastructure that fits these fermentation and downstream processing systems. There are a number of fermentation assets around the globe and around the US, but many of them lack the specific processing equipment downstream of the fermentation to recover the end product. There is a promise ahead, right on the horizon, because we've seen this shortfall in assets for quite some time, and so there are a couple of companies that are coming online very soon that can actually work as contract manufacturers to help scale up and de-risking of the technology before going to building a dedicated facility at a cost of several $100 million. Some of the other challenges I think are less of an issue for precision fermentation. You've seen litigation from the animal industries, trying to prevent manufacturers of plant-based and precision fermentation products from labeling their products milk. Those have all been shut down in the courts. It's pretty clear consumers understand the use of almond milk, or you just put a modifier on milk or meat, and for that reason, those haven't really gained any traction. Additionally, I don't think the political pushback that we're seeing recently in the legislation banning the use of cell cultured meat as a food product, I don't think that's going to go anywhere. First of all, these products aren't even available. It's a non-issue, so I'm largely discounting that. One of the things I think is pretty favorable, everybody's realized they've got to be more efficient with their funds and how they use them. So a lot of the pre-revenue startups have moved away from building their own manufacturing, which is terrific. They're leaning more into the use of co-manufacturing facilities. Uh, and as any food company, a major food company knows that many of them do that also, right? Because food products come and go, the life cycle may be short or long, and so you don't want to hang up hundreds of millions of dollars in an asset that you may only use temporarily. Also promising is we've got um, teams coming together in these incubators, such as Mista up in the Bay Area, where bench scale technology is available for a number of companies to use to test and develop their ingredients and put them into food products, and see how the formulation works or doesn't work. And many of those are funded through partnerships with major food companies. Additionally, there are public funding opportunities. The USDA, National Institute of Food and Agriculture, has some resources available to help bridge the gap between these early lab scale proof of concept and going to pilot scale, if not commercial scale. And then finally, we've had some encouraging progress in terms of legislation and executive orders coming out of the White House. We all here, everybody here clearly appreciates the problem we have with sustainability and greenhouse gas emissions. So there are a number of activities that were initiated within the last year or two that are promising to help support and accelerate the development of these products. So I'd like to leave it there and see if there's any questions from the audience today.
Anyone have any questions? Oh, great.
Hi, thank you for your talk. I was wondering, the approaches for precision-based fermentation, is it always kind of a trial and error or iterative approach, or is there some kind of way to use like be machine learning or AI-driven approaches?
Yes, in fact, we've seen developments in that area over the last decade. I would say, I think we've been working on these iterative scale approaches, right? We can scale down fermentation into microtiter wells, and do multiple conditions and iterations to try to refine what the ideal processes are. Um, and then, now with machine learning coming in, it's a matter of being able to capture the data coming out of those processes to feed them into the learning models and, come up with better predictive approaches. One of the challenges with those very, very small scale fermentation approaches is that it's very hard to get enough data out of them. It's not entirely reliable. It has a lot of noise. The signal to noise ratio is not ideal. So we're still largely relying on 1 liter and 5 liter fermentation approaches to get the best data to feed into those models.
Anyone else have any other questions? Great. Well, we really appreciate your time, Michele. Thank you so much for your presentation. And we're going to move into a brief 5-minute break before we start the showcase. Thank you. And please give Michele a round of applause.